Return to this session of design pattern. In this session, we will try to understand what is bridge pattern. We will go through some sample source code, fundamentals, definitions, so that you can actually visualize that how you can use bridge pattern in actual projects. So the first thing in bridge pattern is that they fall into the structural pattern category. So as said previously that that structural patterns are those the whichever patterns lie into the structural pattern sections are those patterns which helps us to solve the structural issues regarding software architecture. Bridge pattern helps us to decouple the abstraction from the implementation. I hope that everyone is clear about abstraction because it's a very basic object oriented principle. uh, Abstraction means to only to show the necessary things about the object. Okay, what do you mean by necessary things is, for example, let's say that you have a TV and then you have a remote for the TV. Now, in remote, you will see that only the necessary functionalities are there. For example, rewind, to say start, stop, change the channels, make the volume up and down. You know, but definitely the user is not exposed to that how the CRT tube of the TV functions, or how is the internal what you call stabilizer in the TV, or what are the internal electronic equipments of the TV. He is only concerned with that remote, you know, the start, stop, and the volume and the channel. So the abstraction from the a simple user perspective for a TV is that remote. Okay. Okay, and the implementation is nothing but your internal way working of the diodes or the electronic equipments or whatever it is. So again, I'll revise that abstraction is nothing but to show the essential uh, functionalities to the end user. So if you are designing classes, one thing is very important, that you should only expose the necessary features as public properties. So in this way, your object is not complicated. So if we are able to decouple this abstraction from the implementation, right? And if tomorrow, if we change the implementation or we add new implementation, it does not affect abstraction. Okay. So tomorrow, if I put a new TV model, I don't need to change the remote. I don't need to train the user again. The user will still use the same volume button, the same change channel and start and stop. So basically, adding new, changing the TV doesn't change my remote. In short, changing my implementation doesn't change my abstraction. So here's a simple example which we will try to uh, see that how we'll try to make a sample source code of it, and then you can think about how you can implement in your projects, but if you want to implement, you should ask yourself a question, that when should I implement uh, a bridge pattern? If in your project you are seeing situations and scenarios where basically your implementation is changing a lot. Okay, and then you have created some and your I'm sorry, your implementations are changing a lot, you are adding new implementation, etc. And then your object, which is, or we can say, the abstraction of the object or the design of the object, then again needs to be changed again and again, you know or it needs to be recompiled again and again. Then you should think about using BridgePatter. So ask yourself a question, that do I need to separate the implementation from the abstraction? Does my implementation is my implementation so dynamic that I always need to go and again recompile my abstraction? If yes, then you need to use BridgePattern. So here's an example of it. So what I've done is, basically you can have any kind of equipment, any kind of electronic equipment. Okay, but to on those electronic equipment, there is the abstraction is a switch, so it has on and off. Okay, and my implementation can be a fan, so I can, if I need to what you call on a fan, you know if I need to start a fan, I'll just say on the fan, and if I need to off the fan, I'll just say off the fan. So the switch is a very generalized thinking. you know it will start and stop any kind of equipment like AC, TV, radio, anything. And the implementation are the actual equipments, that is the fan, AC, and TV. So tomorrow, if I add a new equipment, right, I should be able to design a system in such a way that I don't need to change the switch. So first thing, as I said, you need to separate the implementation from the abstraction. So first we'll design our implementation classes. So what I've done is that I have started the implementation for every equipment. One is, first is the refrigerator, then is the bulb, and in every of these implementation I have written there, I have a start and a stop method. you know and this start and a stop method can be, just to make it more uniform, I have uh, implemented from a common interface I equipment. Now, every of these start and stop methods have their own implementation. In the sense, for example, a refrigerator to start, right, I need to start the compressor and start the ice cooling. But if I need to start the bulb, I just need to warm the bulb and blow the bulb. In the same way, if I need to stop a refrigerator, I just need to stop the ice cooling and then stop the compressor. If I need to stop the bulb, I just need to switch off the bulb. So implementation of every of these equipments are different. So whatever I've shown you now is the implementation. Now let's go to the abstraction part. My abstraction is a switch, okay, and the switch has the on and off. Now what I'll do is that I'll take a equipment as my reference internally. So what I've done, I've aggregated the equipment interface in the CLS switch, and I will just call the start and the stop. I don't know which equipment I'm starting and stopping, but my which equipment I'm starting and stopping. But because I'm just using this common interface I equipment, I will just start and stop any kind of equipment I want. Okay, so this is my abstraction. If you look, in a very granular way, you know, we were able to use this. We were able to separate the abstraction because of this interface I equipment. So your abstraction is always pointing toward this equipment. So now here's the actual class implementation. So create object of bulb, create object of refrigerator, create object of switch. Okay, if you want to start the bulb and stop the bulb, just pass the reference to the switch object, start and on and off. Now the refrigerator object, on and off. So in this sense, my switch, which is abstraction, is separated from the implementation. I can just create any kind of implementation object, give it to the switch, okay, and switch will just run with the start on and off. So this is how, we have separated the abstraction from the implementation. So tomorrow if I add a new equipment, it doesn't matter to me because they all inherit from I equipment, and I have separated my abstraction and implementation by using the I equipment interface. Let's go through a sample source code, the same source code which we discussed. So here's what I have. As I discussed, that this is my implementation. This is my bulb implementation. This is my refrigerator implementation, and this is my switch. And in the switch, I have passed the equipment, and I've started on and off. Okay. Here's my program. You can see that I have first passed the bulb to the switch, then I passed the refrigerator and just started the on and the off. The same for the bulb. Now, what I'll do, if I run this program, you can see that the bulb first is warmed up, blown, and then switched off. In the same way, when I started the refrigerator, it just started the compressor, started ice cooling, then stopped the ice cooling, and stopped the compressor. This is a very a hypothetical example which I've shown, but in actual projects, when we look into actual projects, right, there are many times, where you would like that you have some classes which are actually doing the work, or we say the implementation, right, and then there is a generalized abstraction for it, and you don't need to recompile this generalized abstraction. When we talk about the generalized abstraction, I mean is these are the classes or the interfaces, which are directly referencing the UI, and the UI is actually using that abstraction. Okay, now you don't want that by adding new implementation, you don't want to recompile the UI again and again. So that is what is in practical terms when we talk about abstraction and implementation. So in the sense, if you don't want to recompile your UI again and again, right, and you still want to add new functionalities to a class or object, or a business object or something, at that time uh, you'll definitely need this pattern. But again, ask yourself a question, that's very important. Any design pattern you read, any design pattern you read theoretically and you try to understand it, but don't try to force the design pattern in a project. Keep your practical thinking in mind first thing, not only theoretical. Ask yourself a question that is the is that my client UI is getting compiled again and again, that is my abstraction is needs to be compiled again and again with every implementation. If yes, then go for this pattern. So uh, any kind of because we have gone through so many design patterns till now, I'm sure, uh, but what you can do is you can keep a list of design patterns with you, you know and you can just also keep the list and a simple definition of it, and see that uh, see that so whenever you have an issue or a problem, right, you just look at the list. Okay, it can be a simple page, with 1 or 2 pages where you have listed all the design patterns and a simple definition. So for example, when we discussed about bridge pattern, we said, okay, it's about separating abstraction and implementation. When we talk about factory patterns, it's about centralizing the object creation. When we talk about visitor pattern, it's about uh, you know adding new logics and not changing the data structure. So in this way, keep a list of it, and then what you do is that you basically look at your problem and see that does it fit to the list, you know and then wear that practical cap in your mind, saying that is it necessary? If yes, then implement that pattern. So that is very essential. Don't get carried away with it. Don't make your project complicated. Finally, always remember that projects the important thing is that projects should be completed on time. They should be designed in a proper way. Okay, not they should not be uh, learning platforms for developers and architects. That's a very important thing, because customers put huge money on projects, and I've seen that in big companies, even in small companies, big company, any kind of company, I've seen that that developers and architects, they try to learn something and then try to work on a project. So just think, how good would it be that if somebody is building a house and then he says that he is a civil engineer who is basically just learning something and trying to implement on this building. You would be definitely scared. So in the same way, the customer also puts a lot of money. Okay, so design which is practical, think what is practical, and keep that list in mind. Okay, but again, see it practical, that if you can solve it in a simple way, probably you don't need to implement that design pattern. But if you think no, that is the best way, then do it. I hope I was able to uh, clarify the fundamentals of bridge pattern. And if you have any kind of suggestions, and if you have any kind of improvements for these videos, you can always mail me at shiv_query@yahoo.com.